Hello everyone. Very good morning to you all. So today I'm going to take a session on rigid pavement. Okay. So first of all, let us clear the plan of a rigid pavement which I have drawn for you. Okay. So this one is a plan or top view of a rigid pavement. This arrow symbolizes the direction of traffic. Okay. This arrow and this arrow. This one is the left portion and this one is the left portion. Okay. Now, mainly in a rigid pavement, there are two types of joint. First of all, that is traverse joint, and second one is longitudinal joint. Okay, traverse joint means we will get under the traverse joint, that is expansion joint, contraction joint, and contraction joint. But here we are only bothered with expansion joint. That means this one is expansion joint, and interior in between these joints are contraction joint. Okay, so now we can say that there are mainly two types of joint for for traverse joint, that is expansion joint and contraction joint, and second one is that is longitudinal joint. Now come to the purpose. What is the purpose of expansion? What is the purpose of expansion joint or contraction joint, or we can say that traverse joint? Expansion joint, from the very beginning, if we see our class 7 or class 8 physics book, then we can find that there is a huge differential changes in the steel, okay, which we can directly see for the railway traffic. But we have to know that for rigid pavement also, where we place steel, there is a influence of expansion and contraction. Okay, so mainly expansion means when the temperature will increase in general, that steel will tend to expand. Okay, and if the sufficient place is not provided, then obviously crack will be there. And same as contraction joint, when the temperature difference is lower, or we can say that in a winter season, mainly steel is try to contract. So we have to leave sufficient spaces to contract. Otherwise, we can see the crack over here. Okay, this zone will be under crack. Clear? Now, second one another important motto for expansion joint is that this expansion joint or contraction joint, we can say that this is distribute the load from the very next slab. So we can find another importance of double bar. Double bars is providing the load from one slab to another slab, whereas we can say also expansion joint or contraction joint is providing as a juncture in between two slabs, and when the load is coming, vehicular load, the main one of the important motto of this expansion and contraction joint is that this is acting as the uh, load transferer. Okay. Now, what is the meaning of longitudinal joint? We all know that as the IRC prescription, as IRC prescribed us that for the single lane, the width of the pavement is 3.75 meter. Now, if the uh, width of the road is greater than 3.75 or much more than, then obviously it is not possible for the pavement to resist the load itself in a single width. For that particular case, we have to provide a joint. Okay, so this one is known as longitudinal joint. Another one of the importance is that this longitudinal joint is acting as the leveling medium for the left slab and right slab. Okay, this longitudinal joint tends to fix the slab in a same level. Clear? Now, if we find that as Westergaard said in his theory that mainly three zone is very important to describe the functionality of a rigid pavement, that is interior zone, edge zone and corner zone. This zone, corner zone. Okay. So why these three zones are very much important? Because interior zone means every a vehicle basically when the vehicle is moving in the interior portion of the pavement, that means the load is coming into the interior zone. Okay, and I think that not my as per my not as per my thinking, as per the Westergaard, interior zone is quite safe, but if we see the corner zone or the edge zone, we will find that these zones are very much severe. Okay, these zones are very much severe because vehicular load cannot rest in a uniform way for the corner zone or the edge zone. So these zones are under the critical condition. So that's why Westergaard gives us the formula Westergaard load theory for three zones individually: interior load stress, edge load stress, and corner load. Okay. So now think that this picture is clear. Also, one more thing. As per the IRC, the difference between expansion joint maximum, that is 141 meter, 141 meter, and contraction joint, in between two contraction joint, the gap is 4.5 meter. So every maximum we can provide two contraction joint. Maximum difference should be 4.5 meter in between two contraction joint. So the gap should not be more than 4.5 meter. Now the design should be as per our calculation. If it is 2 meter or if it is 2.5 meter for two contraction joint, okay, okay, but no problem. Also for expansion joint, if as per our calculation, if it is 10 meter, 20 meter, 25 meter, no problem. But ISK prescribes the maximum difference in between two expansion joints should not be more than 141 meter. Clear? Thank you. Now come to the IIT Bombay lecture. From the very beginning of my classes, I prepared this note. Basically, these notes elaborately discuss all the parts, and you will find very uh, in books there are very short description about this modulus of subgrade reaction, relative stiffness of slab to subgrade reaction. Okay. Now come to the what is modulus of subgrade reaction. 29.1.1 modulus of subgrade reaction. What is modulus of subgrade reaction? I think that all of you have studied the plate load theory. Okay, in foundation engineering. I assume that everyone has studied. Now, what is modulus of subgrade reaction? Now, just listen my word very carefully. Suppose there is a wooden block, okay, and the thickness is almost suppose 2 to 3 meters, okay, and the wooden block, the size of the wooden block is suppose 30 centimeter into 15 centimeter, yes, length and width, and the thickness is 2 to 3 centimeter. Now, everyone can uh, um, idea about that wooden block. Now, if we place the wooden block into the uh, water, suppose we have a water container. Okay. Now we are trying to push that wooden block into the water. What we will see that it it is on the rest. It is in resting condition on the waterful bucket. Okay. So Westergaard assumed that for the rigid pavement, if we see that rigid pavement is acting as that wooden block. Okay. Now soil subgrade is like the uh, water medium or the dense liquid medium. Clear? Now Westergaard assumed that modulus of subgrade reaction is that the displacement. of the that here it is already written, and just have a read, then I am going to clear your confusion. The upgrade reaction is assumed to be proportional to the deflection. Okay, that means the reaction, that means the when the vehicular load is resting on a rigid pavement slab, it is under the deflection, and that deflection is directly proportional to the upward reaction which is provided by the soil or the subgrade. So as per this assumption, Westergaard defined the modulus of subgrade reaction, that is K, and the unit is kg per centimeter cube. And the numerical form of this K is equals to P by del. What is P? P is the pressure which is sustained by that rigid plate, or we can say the rigid slab. Okay, and del is the deflection. What deflection? That is our calculated deflection is 0.125 centimeter. So P is the pressure sustained by the rigid plate, and 0.125 centimeter is the deflection. Okay. Now basically this test is done on 75 centimeter dia plate. Okay, 75 centimeter dia plate, but it is not at all possible for every time to gather 75 centimeter plate, to arrange 75 centimeter plate. That's why we arrange 30 centimeter plate for our better purpose, for our better use. Okay, so this one is the main thing we have to understand. Now relative stiffness of slab to subgrade. What is relative stiffness of subgrade? First we have to read that as per the Westergaard, a certain degree of resistance to slab deflection is offered by the subgrade. Exactly, the subgrade deformation is same as the slab deflection. This line is very much important. The subgrade deformation same as the slab deflection. Okay, basically for this not only for the rigid pavement, this is for all FT type of pavement. The how much uh, slab has been deflected or how much slab has been deteriorated, it can be assumed as per the subgrade deformation. But you can say that the subgrade is the bottommost part. So how it will be possible for understand subgrade at first? So it is better if the slab is under the crack condition. So it is better to understand that subgrade is under the deformation condition. Okay, by viewing the slab itself. If the slab is under the enough deflection, that means subgrade is under the deformation. So we can say that the slab deflection is direct measurement of the magnitude of the subgrade pressure. Clear? So now, all you know that this one is the empirical formula which is given by our Westergaard, that is L is equals to cube pH cube by 12k into 1 minus mu square to the power 1 by 4. Okay, so this one is the formula. L equals to pH cube by 12k into 1 minus mu square to the power 1 by 4. So this one is the formula given by the Westergaard to determine relative stiffness or radius of relative stiffness. Must know formula. So where is equals to modulus of elasticity of cement concrete, which is in general 3 to 10 to the power 5 kg per centimeter square. Mu is equals to Poisson's ratio of concrete, which is 0.15, and H is the slab thickness in centimeter. Slab thickness in centimeter means only the slab portion, not the base course, not the sub base course, only the slab portion, the thickness of the slab, rigid slab, that is concrete slab. Okay, and K is the modulus of subgrade reaction. Here, so what we have studied till now, the plan of rigid pavement, next modulus of subgrade reaction, and relative stiffness of slab to subgrade. Clear? And there are several numerical problems over this formula. Maximum 4 to 5 numbers will be there. They just give they will just provide you all the necessary details like modulus of elasticity of concrete, thickness, uh, modulus of subgrade reaction value, Poisson's ratio. Now we have to calculate only the relative radius of relative stiffness of slab to subgrade. Okay. So in my next lecture, I am going to discuss the leftover portion for the rigid pavement.